All right, we're going to take a few minutes and introduce you guys to the idea of polynomials. Fancy word, but what are they? Here's something you've seen before. This is the expression 2x plus 7. You might have seen this before as well, 2x squared plus 3x minus 4. And you might remember that's a quadratic expression because the power of x is a 2 here. But more than that, both of these things are actually examples of polynomials. So what makes a polynomial? And is this a polynomial? Is this a polynomial? Well, the answer is yes. Yes, they are polynomials. So polynomials are expressions that have unknowns or pronumerals in them, and they have some to the power of, or some index in there. Now you'll see these ones go up further. This is x to the power of 3. This is x to the power of 8. So we're going to talk a little bit about what kinds of polynomials they are, how we name them. We're going to get to know them a little bit. So we're going to pull this one apart. This is the one we started with over here. I'm going to rewrite it over here. We're going to talk about a few features and things about polynomials. First of all, they're made up of terms. Now you'll see I've split with the red lines here each individual term. Now remember, the terms of an expression start at where there's a plus or a minus sign. So this is a term here, plus 2x to the 5. Minus 3 is a term. So polynomials are expressions that are made up of terms. Okay, the first one out the front here is the leading term. Now remember, we write them in numerical order from the highest indexes down. So you'll see this has got an index of 8, this has got an index of 5, and they work their way down. So the one out the front there is what we call the leading term. This one at the end doesn't have an unknown with it, but it's a number. We call it a constant, or we could say a constant term. So we've got a leading term, we've got a constant term. This number in front of the pronumeral, remember we call that the coefficient. We would say this term has a coefficient of positive 2 or a plus 2. All right, nothing particularly new there. We know about terms from previously. So what's the first thing that we can say about a polynomial? They're made up of terms, and we've talked about some of those terms. Also, their indexes must be whole numbers. Okay, so you'll notice the indexes here are 8 and 5. They are whole numbers. Okay, so this is good. This is, so far, satisfies all the rules for a polynomial. What else do we know about polynomials? We name them by the highest degree. Now, the degree is the index. So this has a index. Its highest index is 8. Like the highest index for one of the pronumerals in here is an 8. So let's look at some examples, right? We'd say this one would have a degree of 8. Let's look at some examples and just work our way through. X equals 1, we would call that just wait for the computer to catch up. Oh, sorry about that, it's a bit jumpy. X equals power of 1, but remember, when there's an index of 1, we just don't write the index. And we know them to be linear. That's like this one up here, 2x plus 7. We know if I graph that, it's going to be a straight line. It's a linear equation. If we have an index of 2, then we know that is called a quadratic. Okay, so something like this one up here, it graphs as a parabola. Hopefully you've done them previously, and you will recognize that as a quadratic equation. What about x to the 3? Well, x to the power of 3, when something to the power of 3 is cubed, so we would call that cubic, a cubic polynomial. X to the power of 4, we would call a quartic polynomial. But what happens when we go even further than that? X to the 5. Well, we stop there. We don't kind of keep giving them sort of fancy names. We just say it is a degree of 5. It's a polynomial with a degree of 5. In other words, the index, the highest index in this case, is to the power of 5. We'd say it has a degree of 5. Just like we said, this one has a degree of 8 because the highest index is an 8. What else? They can be written, or they should be written, in what we call function notation. So let's talk a little bit about what we mean by that. Here's my polynomial. Y equals 2x cubed plus 3x plus 1. Now, instead of writing this with the y here, I'm going to write this in function notation. It's a polynomial in x equals, and the rest is just the same. So I've written the same polynomial, the same expression, but I'm written it in function notation. So that means polynomial with the value of x equals 2x cubed plus 3x plus 1. Now, that means I can easily go ahead and I can substitute in values for x. So in this case, polynomial, where the x equals 2, I would write it as p bracket 2, and I'm going to replace each of the x's with a 2. Now, if you've been in any of my classes or seen any of my videos, you would know I'm a big fan of putting a set of brackets in where the pronumeral was. So where the x was, I put some brackets. Where the x was here, I put some brackets and replace it with the values. A couple of reasons for that. I'm going to explain it in a minute. Let's just finish this example and we'll explain it in another example. So now I can put that in my calculator and I'm going to get a value of 23. All right, so I've got a value for that polynomial. In other words, what that means, the 0.23 is a solution because this is my x value. And when I substitute that in, the value that I get is this. So it's an x and a y value. Okay, this is my x value. This becomes my y value, or what I get out of the function. So that point is a solution. Or in other words, I could say that the point 223 lies on this line. So if I was to graph this, the point 223 would be on that. All right, we are rushing through. Let's have a look at a couple more examples of things we can do with polynomials, or questions you might get asked about polynomials. Is this a polynomial? 2x cubed plus the square root of x minus 12. Well, let's have a look. We know from previous work, you should hopefully recognize that the square root of x can be written as x to the half. Now, going back to our quick rules, or our guidelines for polynomials, remember we said that they have to have a whole number as the index. Now, we don't. X to the half is not a whole number. So no, that's not a polynomial because it doesn't meet our criteria with the index having a whole number. Let's have a look at this question here. Evaluate P3 for this polynomial. And it is a polynomial. My indexes are 3, 2, and this is actually has an index of 1. Okay, it's actually the same thing as half x. So half x, x to the power of 1. So yeah, it's a polynomial. I'm going to evaluate when x equals 3. So remember I said I'm a stickler for putting in a set of brackets wherever the pronumerals were. Here, here, and here. I'm going to talk about why in a second. All I need to do now is put the value 3 in wherever my brackets were. So I'm going to replace each of those bracket spaces with the value of 3. Now, I can put that straight into my calculator exactly as I see it. And this is why I love the brackets. Because the calculator, your scientific calculator, will know with what the brackets mean. Okay, and it will give you the right answer. Okay, so if I put that into my calculator exactly as I see it, I'm going to get a value of 73.5. So in other words, the point 373.5 lies on the line. It's a solution. Now, here's why I like to put in the brackets. Now, if you wrote this without the brackets, and you might think, yeah, I'm pretty good with algebra. I know that this bit here, 3x cubed, if I replace the x with a 3, I know this means this. I'm going to replace this x with a 3. All right, so far so good. And I'm going to, because I'm pretty confident, I'm going to do this in my head. 3 cubed is 27, so I got 3 times 27 minus 3 squared. Well, minus 3 times minus 3 is positive 9. Plus 3 over 2. Yeah, no worries. I put in my calculator. I get a value of 91.5. What gives? That's not the same as this. Now, here's why I love the brackets. Because in an exam, you're rushing. Your brain's got a million things going through it. A lot of people I've seen make this mistake. They've replaced the x here with a 3. And they've gone, oh, minus 3 squared is a positive 9. But that's not what's happening. We've got a minus 3 squared. Okay, you'll see over here when I did the brackets, the 3 squared happens, then the negative gets applied to it. So the calculator will know. If you do it in the brackets, the calculator will do the order of operations correctly. This is a real common mistake, and it's why I ask people usually put the brackets in, because that is the wrong answer. Ladies and gentlemen, that is your crash course, real quick intro to polynomials. Well done.